So you guys have seen the original sine and cosine graphs. We've changed the period, we've changed the amplitude. Now we're moving on the last two changes, I suppose. We've got horizontal translations and we have vertical translations. So translations literally means like shifting the graph, like left, right, up, down. So what we're going to be doing first is the horizontal translation, and that's known as the phase shift. So the official definition is a horizontal translation of a periodic function. So each cycle, goes over and over again, starts at a certain point, ends at a certain point. So you can consider a cycle to be like one phase of the periodic graph, and if you shift it, that means where that phase starts is being shifted. So that's why they call it what they do. So if you look here, this is the original sine graph that they're showing, like the darker one. Starts here, goes up to its high, 0, low, 0, and then keeps it going. What they did, see if you have theta minus h, if h is positive, then it'd be like theta minus 2 or like theta minus whatever. It moves over to the right. Remember when you're doing like left and right stuff, it's always opposite of what it appears to be. And then this one, this dark one is your original sine graph again. And then if you do h minus a negative number, which would look like theta plus, then it actually moves to the left. So I'll just give you two examples really quickly so you know what I'm talking about. So for example, say your graph looked, or your function looked something like this. It looks like that. What that would be is you'd shift 90 degrees to the right. Remember, always kind of opposite of what it seems when you're doing left-right shifts. The minus seems like it should be left, but it's actually right. Or, for instance, you could have like a tangent graph with a theta plus 30 degrees on the inside. And the plus 30 actually means you'd be going 30 degrees to the left. Again, left, right are always kind of opposite of what you think they're going to be. So let's look at an example here. Here's our function. We want to find the amplitude, the period, and the phase shift. So amplitude and period are done the exact same way they were yesterday. So the amplitude is still just whatever number is right out front attached to either sine, cosine, or tangent. So that's a 2. So that means like this one, instead of going up to a high point of 1 and down to a low point of -1, it goes up 2 units, down 2 units. And then the period, we have a formula for that. It's always 360 divided by b, and b is whatever's in front of the theta. And we don't see anything in front, which means it's technically a 1. So it's just a normal period. Nothing changes. Starts at 0, ends at 360. And then the plus 45 inside means that our phase shift is 45 units to the left. 45 degrees, I'm sorry, to the left. That plus means you go in the opposite direction. Okay, so here's what I want you guys to set up. So your y-axis, let's graph this in here. Everything's moving to the left, so I'm going to have to graph a little bit more over to the side here. My amplitude is 2, so I know it's going to go up to 2, down to -2. And then let's talk about this pattern. All right, so a cosine pattern normally goes, high, 0, low, 0, high. It would start at 0. It would end at 360. Then the middle point would be 180. Then you'd have 90 and 270 as the 1/4 and 3/4 marks. So here's what I would normally mark on my theta axis if I didn't have a phase shift. All right, so that's always what I want you to start with first. Look at the period, kind of mark down where these points would be on the theta axis without a phase shift. Then, right underneath, like with the phase shift, I want you to move everything 45 degrees to the left. So basically you're just subtracting 45 from all of those values. Okay, so 180 minus 45, 270 minus 45, and 360 minus 45. Okay, so that's where your 5 points are going to be. And because it's a cosine curve, you're going to graph high, 0, low, 0, high at those 5 points. Okay, so let's mark on, here is a negative 45 degrees. Okay, then this would be a positive 45 degrees. And then 90, 135, 180, 225, 270, 315, and 360. Okay, so I tried to do a decent job of spacing those out. All right, so my first point of this particular cycle starts at negative 45 degrees because of my phase shift, and it's at its high point because it's a cosine graph. Its high point is up here at 2 because I changed my amplitude. Then next, I go back to 0. So at 45 degrees, I'm right at 0. Then my third point, 135, I'm down at my low point, down here at negative 2 because my amplitude changes. Point number 4 at 225, at a value of 0. And point 5 at 315, I'm up at my high point, so it lands right up here. Okay, so now kind of fill in, and remember, it doesn't just exist with this one cycle that we're graphing, so you always want to kind of do a little bit more on both sides to show like, yeah, it is going to keep going to the right, it's going to keep going to the left, we're only showing one cycle here. Okay, so that's what a horizontal translation looks like. Normally, like this right here would have been at 0, but I took this whole graph and just pushed everything 45 degrees to the left. All right, vertical translation, vertical shift is exactly what it sounds like. It is a vertical translation, and vertical means up or down. Okay, so here's what you see here. So this time we used a cosine graph for the picture. So here's the original cosine graph in the solid line. And then if you have plus k, that moves it k units up. If you have plus k and k is negative, so it would really look like minus k, you're going to move k units down. So for example, just to provide you with another little reference, say you had a sine function and then you had a plus 4 on the outside. Now, big difference. It still looks pretty much the same, like you have like theta minus 90 or like theta plus 4. Big difference is this one's in parentheses. So if you have a phase shift, it will be in parentheses with the theta. If you have a vertical shift, it'll just be kind of tagging on its own on the end. Okay, so this means you're going 4 units up. Up and down actually is what it looks like. Plus 4 actually is up. But let's say, for instance, you had a cosine graph and then like minus 3 on the outside, not in parentheses, but separate on the outside, you would go 3 units down. Okay, so let's see our example of that. So we are going to look at a vertical shift example. Oh, I'm sorry. First, we're going to define something called the midline, which is very important. So the midline, normally with my pattern, I was saying like, 0, high, 0, low, 0. We're going to change that a little bit because now if I move everything up, it's no longer focused around 0, it's focused around wherever I move it to. So the midline, this is kind of a fancy definition, it is the horizontal line about which the graph oscillates. So for sine, it's like it starts here, it goes up, but it comes back here. It goes down and it comes back here. So the midline is kind of like our home base about which the graph oscillates. So it goes the amplitude units up, back to the midline. Amplitude units down, back to the midline, and then it repeats. All right, so with that in mind, here are our new patterns. Sine, we're no longer going to write 0, high, 0, low, 0. We're going to write midline, high, midline, low, midline. Okay, so maybe the midline's 0 if there isn't a vertical shift, but we're going to write midline. That's a more generic answer. So cosine goes from its high point, and then instead of 0, we're going to say midline, down to the low point, back to the midline, and then it finishes the cycle at the high point. Okay, so those are our new patterns that we're going to go with. For example 2, I made a mistake. I copied down the wrong function there, so can you rewrite this as y equals 2 times the sine of theta plus 2. Okay, so please make sure you rewrite that, otherwise if you don't rewrite it, you're looking at a very different function. Okay, so we're going to write the amplitude. Still find the amplitude the very same way. It is just the number that's attached, either sine, cosine, or tangent. So here it's 2. The period, same thing. We still find the period the very same way. We take 360 and we divide it by whatever's in front of the theta. Now we don't see anything, which means it's 1. So our period is still just kind of the standard period. And then the vertical shift, we have a plus 2 on the outside, so this is going to go 2 units up. All right, so sorry, I kind of boxed this in. Okay, so those are all three of our changes that we're going to be making. So let's set up our axis. So we're going to set up based on our amplitude and based on our vertical shifts. So the first thing we know is everything's going to be pushed 2 units up. So I no longer want to use 0 as my midline here. I'm gonna put my 0 down here. This will be my normal theta axis. So here's theta, here's y. Now everything's going to get moved 2 units up. So that's 2. So what I want to do is I'm going to draw in a little dotted line here. This is my midline. Everything is kind of based around that line instead of around this line now because I moved everything 2 units up. Okay? Then for my amplitude, my highest point is going to be up 2 more units and my lowest point is going to be down 2 more units. Okay, so I kind of took care of my vertical shift, kind of took care of the amplitude. There's no phase shift, so it's just going to start at 0 like normal, and then my period is 360, so the cycle will end at 360. The middle of the cycle will be 180, 90, 270. All right, so from the midline, we are going to graph our sign pattern. Our sign pattern goes middle, high, middle, low, middle. All right, so that is one cycle. Always graph just a little bit past it so you can show the fact that the graph will keep going even beyond the one cycle that we graphed. All right, so there's our example of a sign graph. Okay, now this right here, we're going to label that is the midline. It is y equals 2 in this specific example. Okay, so now we've seen a bunch of different things all kind of separated. Like we haven't yet changed like the period and the vertical shift and the phase shift at the same time. So I'm going to give you guys a step-by-step of how exactly you would do that, kind of what order makes the most sense. So if you have all of these, so notice you've got A's, B's, H's, and K's for all of those, and they represent all different pieces. So first, very first step would just to be to find the vertical shift. Find the vertical shift, and that is based on your value of K. All right, so you either go K units up or you go K units down. And then you're going to graph the midline. Okay, so notice that's kind of the first thing that I did here. I noticed there's a +2, so I moved 2 units up and I graphed my midline there. That's where the graph is going to oscillate around. Okay, so that's step 1. Next, find the amplitude. And amplitude is A, whatever this number is in front of the cosine, the sine, the tangent. Use this to label the y-axis. So you want to know where the maximum point is. You want to know where the minimum point's going to be. So here I had an amplitude of 2, so I knew that from 2 I was going to have a maximum of 4 and a minimum of 0. So I kind of marked that onto my y-axis to know how high and how low my graph was going to get. Step 3, find the period. That formula is 360 divided by b, and b is whatever is right here in front of the theta. And then from that, you are going to determine the 5-point pattern for theta. All right, so here the period was just 360, so we determined the 5 points were 0, 90, 180, 270, and 360. All right, the 5-point pattern that you can start graphing these 5 points. But last thing is that you might have a phase shift. All right, so you find the phase shift. And that is just the value of h. Notice my formula has a minus h, so it already kind of accounts for the fact that you do the opposite of what you see. Because if you had like a +2, that would actually be minus -2, so your phase shift would be -2. So it takes care of it there. And then what we do is we translate this pattern accordingly. Okay, it's like that one on the previous page where I started with 0, 90, 180, 270, and 360, but then I shifted them all 45 degrees to the left. Okay, so let's see an example. We've got all 4 things going on here. Okay, so state the amplitude. So the amplitude is whatever you have right in front here. That's 2. The period is normally 360, but you see we got a pi over 2 in here, so that means we're going to do things in terms of radians. So here's an extra little thing right here. Instead of 360 divided by, we're going to do 2 pi divided by. Either in radians or in degrees, you should be able to graph it either way. And then there's a 1/2. So 2 pi divided by 1/2, that's the same as 2 pi times 2, multiplied by the reciprocal. So I get 4 pi. So it takes 4 pi to go through a full cycle. All right, my phase shift is pi over 2 to the left. Pi over 2 units to the left. And then my vertical shift is going to be 2 units down. Okay, so that is what I'm going to start to set up here. All right, so set up your y-axis. We're going 2 units down, so my midline is going to be, let's call this the midline. So this is the line y equals -2, which means my axis would actually be up here. So that's my theta axis. So first thing I'm doing is I'm graphing this midline. Here it is, -2. Find the amplitude, A, that's 2. So label the x-axis. So I can go up 2 points, so this will be my highest point. I can also go down 2 units, so this will be my lowest point. So these points down here will be the minimums. These points right here will be the maximums. Okay, then find the period. So it should be 360 over b. Let's add in a note that it could also be 2 pi over b if you're in radians. So the period is 4 pi. Okay, so if I split that up, here's my old pattern. All right, so my old theta pattern started at 0, ended at 4 pi. So the middle would be 2 pi, the quarter point would be pi, and the 3/4 point would be 3 pi. All right, so that's the old way that I would have labeled the theta axis if I didn't have a phase shift. Okay, but the new way is I'm going to move everything pi over 2 to the left. So 0 minus pi over 2, pi minus pi over 2, 2 pi minus pi over 2, 3 pi minus pi over 2, and 4 pi minus pi over 2. Okay, so that is the new way that I'm going to label the theta axis. Okay, so over here, let's label this -pi over 2. This is pi over 2. So here's pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi. Okay, so there's my last 5-point pattern. Okay, so then I guess I should technically have a 5th step. Last step is to graph the pattern. So our pattern is cosine. Cosine starts up at its high point. Then at point 2, it goes to the midline. At point 3, it goes down to its minimum. At point 4, it's back to the midline. And at point 5, it goes up to its maximum. Okay, so always show a little extra like this. Okay, so that is one cycle of that particular cosine graph. All right, we've got one more problem to look at on the next page. Okay, so this one we're going to come up with our own trig function ourselves, and then we're going to graph it. Okay, so if we read through, it says the height of water in a wave pool oscillates between a maximum of 14 feet and a minimum of 16 feet. So the first thing we can do is find the midline. It'll be halfway in between those. Okay, so the midline, remember doing like the midpoint stuff? Add them together and divide by 2. So it's 20 divided by 2, which is 10. So my midline is 10. Okay, so let's write just the generic cosine graph here. Okay, so my k, that's the value of 10 that I need to put in. Okay, so we got one of the 4 down. And then the amplitude is pretty easy to figure out, because like from 10, I go up to 14 and down to 6. So that means I'm going up 4 units, down 4 units. So that's A. And then the last thing, this 5 waves per minute. Okay, so that's going to help me find my period. So it's 5 waves per minute, which means, let's see, let's make up our own units here. Here you go, waves per minute. What that means is there's a wave every 12 seconds. Okay, so that's my period. My period is 12 seconds. But I have a formula for that, remember. So my period is defined to be 360 over b, and I know that's equal to 12. So I just do a little like cross multiplying equation. So b times 12 is equal to 360, and if I divide both sides by 12, then I get 30. Okay, so those are all of my values. I've got k, 4 for a, and then I have 30 for b. They don't mention anything about a phase shift, so we don't need to say anything about a phase shift. So my equation is y equals a is 4 times the cosine of b is 30 times theta, and then plus 10. So that's my equation. First of all, that's part of the answer. And now that I know all those values, let's set it up. So here's my y-axis. All right, so my theta axis is going to be all the way down here. And then I'm going to go, let's see, 2, 4, 6, 8, 10 is the midline. And 12, 14. So 14 is my maximum, 6 is my minimum values that I'm graphing. And then B is 30, so I know that my period is 12 seconds. So you can kind of draw in what those 12 seconds would look like. Okay, so 12 seconds. This right here would be 6 seconds. I guess I'm sorry, this really shouldn't be theta. This should be in seconds. That should be in time. Halfway here would be 3 seconds. Halfway here would be 9 seconds. All right, so based on all this stuff, I'm going to graph my cosine curve. So I start off at my maximum point for point 1, then the midline, then the minimum point, back to the midline, and then I finish up here at my maximum point. So start drawing that. Now I guess I really shouldn't draw to the left because that would be before time starts, and we don't graph negative time, but could keep going to the right. Okay, so you can see it oscillates between a maximum of 14 and a minimum of 6 feet, and it pumps out 5 waves per minute. So this is 12 seconds. If I kept graphing up to 60 seconds, you would see 5 of these full waves. All right, so that's it.